All right, so the tangent ones are a little harder to do. So at what angle is a tangent equal to 1 at? At what angle is a tangent equal to 1 at? So get out your unit circles, look at them. See if you can figure out where the tangent would be equal to 1 at. Well, 45 degrees. And people go, well, I don't get that. Well, tangent, remember, is y over x. So y over x has to equal 1. Okay? Don't put your calculator lid on the wrong direction. It makes it really hard to get off. Okay. Where is the tangent equal to 0 at? So y over x has to be 0 over something. So where is y 0 at? 90 degrees. No. Y is 0 at 0 degrees, not 180, because we don't talk about tangent being at 180. We talk about tangent being anywhere from negative 90 to 90. So at 0 degrees, the tangent is 0 because it's y over x. Yep. No, you get to use your unit circle, but you have to memorize what x and y over x and 1 over x and all that. Yes, you have to memorize those. Okay, that's nice. Now, where is the tangent equal to negative square root of 3? Okay, now this is a little harder. Okay, so there has to be a square root of 3 involved in either the x or the y. Okay, so it must be either negative 30 degrees or negative 60 degrees, right? So which one should we try? Negative 30. So at negative 30 degrees, what's my y value? Negative 1 over 2. What's my x value? Square root of 3 over 2. Now, from algebra 2, what kind of a fraction is this? It starts with a C. Complex. It's a complex fraction. How do we get rid of a complex fraction? Well, you multiply it by the denominator of the denominator. What's the denominator of the denominator? 2. So we're going to multiply the bottom by 2 and the top by 2. So you get negative 1 over square root of 3. Can we leave square root of 3 on the bottom? No. So you multiply top and bottom by square root of 3. So you get negative square root of 3 over 3. Is that equal to negative square root of 3? No. So it must be this one is negative 30 degrees. So what do you think this one is? Probably negative 60 degrees. So let's look at the tangent of negative 60 degrees. The tangent at negative 60 degrees equals negative square root of 3. Wait, it's square root of 3 over 2, right? No, it's negative square root of 3 over 2 over positive 1/2. Again, it's a complex fraction. So Maggie, how do you get rid of a complex fraction? By of the denominator. So if you multiply by the denominator, multiply each of them by 2. These cancel. 2 and 2 cancel. You're left with negative square root of 3. So negative 60 degrees was correct. Okay, so the tangent ones are going to be a little bit more difficult, but after you do them enough, you might remember them. Okay? So we'll do some like that are like the warm-up exercises. And then we'll go back to triangles and figuring out, all the parts. So if this side is 1 and this side is 2, what's this side? Now, what type of triangle is it? Right triangle. So the missing side is the hypotenuse. And this Greek guy by the name of Pythagoras said what? C squared equals A squared plus B squared. Okay? The hypotenuse, the square of the hypotenuse is equal to the sum of the squares of each leg of a right triangle. That's what Pythagoras said, but only in Greek. So let's do the Pythagorean theorem here. C squared equals A squared plus B squared. C squared equals 2 squared plus 1 squared. What's 2 squared? 4. 4 plus 1 is? C squared equals 5, so C equals? So if that's the square root of 5, what's the sign of alpha? Alpha's there. 1 over square root of 5. Can we leave square root of 5 on the bottom? No. Multiply by top and bottom by square root of 5. You get square root of 5 over 5. What's cosine of alpha? 2 over square root of 5. So you multiply top and bottom by square root of 5. So you get 2 square root of 5 over 5. What's the tangent of alpha? 1 over 2. Opposite over adjacent. 1 over 2, you're done. Secant of alpha. Secant is the reciprocal of cosine. So you take the cosine and you find the reciprocal of your original part there. So instead of 2 over square root of 5, it'd be square root of 5 over 2. Cosecant is the reciprocal of what? Cosecant is the reciprocal of sine, which is? You take the original one, square root of 5 over 1, and that just reduces to square root of 5. And cotangent is the reciprocal of tangent. What's the reciprocal of 1/2? 2. Okay? So we'll have a little bit of that, kind of a review. Then we'll have something like this, which just a little bit different. The longer leg is 4, the shorter leg is 3. What's your hypotenuse? 4 squared plus 3 squared is 16 plus 9 or 25, so it is? Yeah, the square root of 25 is 5. Yeah. Okay. What's the sign of alpha? Well, where is alpha on this triangle? Up here. So to find the sine, it's what over what? 4 over 5. Okay, we don't always just use this bottom angle over here. So it's 4 over 5. What's the cosine of alpha? 3 over 5. What's the tangent of alpha? 4 over 3. Okay? So, now let's look at beta. What's the sign of beta? 3 over 5. Notice how the cosine of alpha and the sine of beta are the exact same thing. Because we used alpha is opposite over hypotenuse for the sine. And then, the cosine of alpha is 3 over 5, okay, adjacent over hypotenuse. And with beta, opposite over hypotenuse is 3 over 5. So notice how those two are exactly the same, okay? What's the cosine of beta? 4 over 5. Hey, that's the exact same as the sine of alpha, okay? Because you're using the same parts. You're just using a different angle. What's the tangent of beta? 3 over 4, the reciprocal of this one. Okay? All right, let's do that again for one more triangle. What's the missing side on this one? Well, what's 17 squared? 17 squared is like 289. 289 minus 64. 225 square root of 225. 15. I don't want you on my screen. Get off. 15. Okay? So, sine of alpha. Alpha is here. Sine is opposite over hypotenuse. 15 over 17. Cosine of alpha. 8 over 17. Tangent of alpha. 15 over 8. Now, we're going to use beta. Sine of beta. 8 over 17, which is the same as cosine of alpha. Cosine of beta. 15 over 17, which is the same as the sine of alpha. Tangent of beta. 8 over 15. Okay, opposite over adjacent. So you should be, by now, getting comfortable with SOHCAHTOA. Okay, you'll do that enough on today's assignment. Now, where that leads us to is finding missing parts of a right triangle. Okay, which is called solving a right triangle. You'll be given 3 parts, you'll have to find the other 3 parts. So if we know A is 2 and B is 8, how do we find C? Pythagorean theorem, 4 squared plus 64, or 2 squared, which is 4, plus 64, which is 68. Square root of 68 breaks down. How? Square root of 4, square root of 17, so it's 2 square root of 17. Okay? Now, do I need that exactly? No. I could do it as a square root of 68. Why? Because it says round to the nearest tenth. So it might be easier to just leave it as square root of 68. Okay. What is square root of 68 round to the nearest tenth? 8.2. Okay. So now we're finding the approximate measure of angle alpha. Now, what should I use? Should I use 2 and 8? Or should I use 2 and 68? Or 8 and 68? Well, I would prefer to use 2 and 8. Why? Because they're nice numbers. Okay? So if this is the opposite side and this is the adjacent side, what trig function am I going to use? Opposite and adjacent is tangent. The tangent of my angle A equals 2 over 8. Hey, this is like our warm-up exercises. If you move the tangent to the other side, it's the inverse tangent of 2 over 8, or 1/4. What's the inverse tangent of 1/4? Calculator. 14.0. So now if I want to figure out angle B, I'm going to use my 2 and 8 again. So I'm going to use 8 over 2. So the tangent of angle beta is 8 over 2. Or if I move the tangent over, take the inverse tangent of 4. 76.0. What's 14 plus 76? 90. How many degrees are there right there? How many degrees are there in a triangle? Did I even need to calculate this out on a calculator? No. Once I know this is a right triangle, so this is 90. Once I know this is 14, I should be able to subtract and get this as 76. To double check, you can always do the tangent, but you should be able to do that. Okay, let's do this one. C is 26. C is my what side? Hypotenuse. Alpha is 17 degrees. So if this is 17 degrees, how do I find angle beta? What trig function do I use? Chirp, chirp, chirp. You can hear the crickets chirping because, you don't use a trig function. Yeah, the triangle adds up to 180, right? If you have 90 of it here, the other two angles share 90 degrees. So if this is 17, how big is angle beta? 73 degrees. Now, it asks for sides A and B. How in the heck do I know what sides A and B are? Well, this is how we do it in trig. If this is angle alpha, side A is opposite of it. If this is angle beta, side B is opposite of that. Now we know which one is side A and which one is side B. Okay? If I have my hypotenuse, I want my opposite side of 17. Opposite hypotenuse is what trig function? Sine. The sine of my angle, do I have my angle? Yep, 17 degrees equals my opposite side A over my hypotenuse, 26. Now, how do I get A alone? Multiply by 26. On your calculator, take 26 times the sine of 17. You can figure out what A is. What do you get? 7 point? Okay. Let's say I want to find B from the 17 degrees. B is the adjacent side, so I use what trig function? Cosine, because I know my 26 is my hypotenuse. I don't want to use 7.6 when I'm trying to figure this out because that's a rounded answer and could throw my other answer off. So I want to use what I'm given at the start of the problem, the 26. So the cosine of 17 equals B over 26. What do we do to each side? Multiply by 26. Take 26 times the cosine of 17. What's 26 times cosine of 17? What? 24.9. That's solving right triangles. We're given three things, the 90-degree angle and two other parts, and you can find everything else from there. Okay? Let's do one more. Okay, a boat from the top of a lighthouse. Here's a lighthouse on a beach. Well, on a rocky coast, probably. There's some water. And out here a ways, there's a little green boat. Okay? How far is the green boat away from the base of the lighthouse, which is the shore, if the angle of depression from the lighthouse down is 43.2207 degrees and the lighthouse is 70 feet high? How far away is the boat from the base of the lighthouse? All right. The angle of depression is the same as the angle of elevation from the boat to the lighthouse. Why? Why are these two angles, this one here and this one here, the same? Because we have parallel lines here. These two lines are parallel and they are alternate interior angles. Okay, from geometry. So I know this angle is 43.2207. That's my opposite side. This is my adjacent side. Opposite and adjacent is tangent. So the tangent of my angle, 43.2207, it's always tangent of the angle, not tangent of the side. Tangent of the angle equals the opposite side over the adjacent side. How do I solve for x if x is in the denominator? How do we get x out of the denominator? By multiply by x. Multiply by x to get x out of the denominator. So x tangent of 43.2207 equals 70. Divide by the tangent of 43.2207. And x equals what? What's 70 divided by the tangent of 43.2207? 74.5. So the boat is 74.5 feet from the base of the lighthouse. Okay? Little bit of trig. So you're going to be over the next, from now until 1:32, for the next 2 hours, you're going to be working on solving trig functions. But there are a few breaks in there. like lunch and a candidate reveal and pride again. So there you go.